Hello everyone, welcome to the video today. Today we're going to have a look at curve sketching. So we're going to be looking at what sort of tools we have available to find different sort of parts of curves. And so we're going to be looking at minimums and maximums and points of inflection. So let's just begin, shall we? So stationary point. So a stationary point is when you get a flat line, so a gradient of 0. So if we're trying to find a stationary point, what we're trying to solve is where the derivative is equal to 0. Okay, where the gradient is equal to 0. And when you find that for a function, when you solve for what x values where you get the derivative equal to 0, it could either be a minimum, a maximum, or a point of inflection. Okay, so you know what a minimum turning point looks like. It looks like that one there. You know what a maximum turning point looks like. It's that one there. The ones you may not be aware of are the points of inflection. So sometimes you get these curves. I haven't drawn it very well, but sort of, like your x cubed sort of thing. I haven't drawn that very well either because it's when it comes up, it flattens out for a second, and then I still haven't drawn it very well, but a bit more curved sort of thing. You get the idea that it sort of curves up like the x cubed curve, and it could go up like that or down like this one here. Okay, so let's just have a think about, just before we sort of get into an example of like how we sort of find these things, let's just have a think about the gradient at each sort of point. So looking at the minimum, let's have a think about the gradient to the left of that turning point. So the gradient as it sort of goes downhill will be negative. The gradient as it goes uphill will be positive. You get positive gradients sort of going, because you're going sort of uphill. If you think about walking from left to right, positive is going uphill and negative is going downhill. Okay, so you've got minimum to the left, negative from minimum, you've got a negative to the left and positive gradient to the right of it. Maximum is the opposite. You've got positive to the left and then negative gradients to the right. Okay, and that's what creates a maximum. And the points of inflection, if you think about it, to the left of a point of inflection, if it's a increasing point of inflection, it's positive gradient, and then after it's positive gradient. Okay, so it just continues to go up after the point of inflection, and for a one that's going down, it's negative before and negative after. And so what we can do, if we know a certain turning point, let's say that we know that there's a turning point when x is equal to 2, we can sort of have a look and sort of think, well, what's the gradient to the left and the right of that point? And if we can sort of figure out, well, let's sort of do a quick example. If we find out the gradient is positive to the right of it and negative to the left of it, we know that the shape will be like that, a negative gradient and a positive gradient. If we know that it's positive and negative, then the gradient will go up and then down, so it will be a maximum turning point. And if we know that it's negative there and negative there, we know it goes down and then keeps going like that. So what we do is we set up a little sign diagram, a little diagram to go, well, what happens? What's the behavior to the left and right of that point? And that will give us some clues as to what it looks like. Okay, so let's have a look at a problem here. So find the stationary points of this particular graph, and f of x equals x squared e to the x, and state their nature. State where f of x is strictly decreasing. Okay, so let's have a go at this. And so whenever you're asked to find stationary points, the first thing to do is find the derivative. So let's do it, f dash of x. So this is a product rule function. It's a product of two functions, x squared and ex. We need to find the derivative. So the derivative is equal to the first function, x squared, times by the derivative of the second function. The second derivative of e to the x is e to the x, plus the derivative of the first function, 2x, times by the second function, ex. So there is my derivative all nicely done. Fantastic. Now I need to solve where this thing is equal to 0. Okay, so for stationary points, so I'm just going to say stationary points, I want f dash of x equal to 0. We're solving that. Okay, so therefore we've got x squared e to the x plus 2x e to the x is equal to 0. Okay, so let's factorize this. There's a couple of things that we can take out here. We've got e to the x in both of those terms, and we've also got an x in both terms. So let's take those out. So we've got x. Oh, that's a funky x. Okay, so we're going to take x e to the x out. What have we got left over in that first term? It would be x. And what have we got left over in the second term? That'll be 2 when we take that out is equal to 0. And so therefore, what have we got? Now, either x is equal to 0. Now, can e to the x, can this here, that there, can that be equal to 0? No, that'll never ever be equal to 0. It's impossible, so we don't need to consider that. But the other part here, if x plus 2 is equal to 0, or x equals -2. So what this is saying is that we've got stationary points at either at both x equals 0 and x equals -2. So we've found out that there's stationary points here. Let's just quickly find the y value of that. So we've got 0 when x is equal to 0. Y is equal to 0 times e to the 0 times 1, but that's just 0. So we've got 0, 0 is a stationary point, and we've also got the point -2. When x equals -2, we've got, I'm just going to do some working out over here, then it'll be equal to 4 times e to the -2. So I'm just going to write that, 4e -2. So that's my the coordinates of the stationary points for this particular graph. Okay, so so now what we want to do is find the nature. So what I do is I draw a line and I say, well, I've got at -2 and at 0, and let's have a think about the gradient in each of these different regions. What's the gradient there? What's the gradient there? And what's the gradient there? Okay, so that's where we're at now. So let's get rid of those. Let's actually think about it. So let's do this one out here first. So what you do is just pick any number. So I'm going to pick 10, right? So a number, usually to pick a big number, something out there. And let's have a think about this gradient. Scroll up a little bit. That gradient there, will that be positive, negative, or 0? It won't be 0, but positive or negative when x is equal to 10, okay? I'm just going to actually, instead of looking at that, I'm going to look at this version because it's a little bit easier because it's factorized, a little bit easier to see. So if we've got positive 10, then x is positive. All right, I'm just marking things on here. E to the power 10 is positive. So I've got positive times a positive, and 10 plus 2, that's also positive. So it's going to be positive times a positive times a positive. So that means the gradient out there is going to be positive. All right, good. I'll just get rid of all that rubbish. And I'm just going to put positive there. Let's have a think about in this region here. So something between 0 and -2. Let me choose -1, right? If I put -1 into there. If I put x equals -1 into our derivative, that bit, why did I do a dot? That bit there will be negative, because we've got -1. E to the x, so e to the -1, that's going to be positive, because that's 1 over e, that's a positive number. And -1 plus 2, -1 plus 2 is a positive, so that'll be positive in there as well. So negative times a positive times a positive. In here, that will be a negative. Okay, just clear my working out there and then put my negative back in there. And lastly, let's have a think about out here. -2, so let's just do -10. Let's just choose something obvious. So x -10, that'll be negative. E to the power -10 will be positive. And -10 plus 2, -8, so that'll be negative as well. So negative times a negative, that's going to be positive out here. And so that gives us a bit of an idea. So positive, negative, positive. So the graph will look something like that. And so this tells us, and I'll just write it here. So therefore, our -2 for e to the -2, that one there is a maximum turning point, and 0, 0 will be a minimum turning point. Okay, so that's what the question asked us to do, I'm pretty sure. Let's have a quick, find the stationary points of that and state their nature, state where it is strictly decreasing. Okay, so let's have a think about it. Where is the graph decreasing? What that means is where is the gradient negative? So where is it going down? And so therefore, f of x decreasing when, and I'll just put x in. Let's just have a think about this. It's going to be decreasing here, right? So that bit there, where it's going downhill. But the other thing we need to think about is how about at when x is equal to 0. Now, when x is equal to 0, remember that's one of our stationary points, so it's actually flat. It's flat at that point, and it's flat at that point. So we can't include the points -2 or 0 because it's not decreasing at those points. The gradient's actually equal to 0, so we can't say that the gradient's negative there. So what we're going to say is x is between -2 and 0, not including the points -2 or 0. And that's all we need to do. Hope that all makes sense. See you in the next video.